Gamak started as a local and the only electric motor manufacturer in Turkey in 1961 and its premises of 38,000 square meters in Istanbul. Its quality-first concept has been duly perceived by its customers very shortly and was attributed to be a number one supplier in the marketplace among its foreign competitors. In 1980, after moving to its new and modern premises of 320,000 square meters, of which 42,000 square meters is closed area, Gamak gained the capability to control and coordinate the production steps more effectively by taking the advantage of all shops being at one site. Gamak is proud to serve all customers worldwide with its production capacity of 1,200,000 motors per year and well-organized team of 1,000 employees and an exceptional R&D department. Our production range consists of low-voltage standard and high-efficiency motors, multi-speed motors, single-phase motors, motors integral with frequency converters, brake motors, smoke extraction motors, open drip-proof motors and fan motors. Additionally, medium and high voltage motors up to 11 kV are produced as per customers' requests. The raw material coils of high-quality silicon steel are taken to the first fabrication step for slitting. Coils of 1000 mm width are cut in different sizes for their use in stator and rotor laminations. The slitted coils are then taken to high-speed presses for punching with progressive type dies. Each of these presses have the capacity of punching up to 400 tons of force and speeds of 600 punches per minute. After the laminations are punched, they are submitted to a treatment process to ensure their electromagnetic characteristics where necessary. The rivets produced with this machine is a small example to show that all parts in the electric motor are manufactured in-house. The stator and rotor packs are formed by riveting the punch lamination steels of 0.5 thickness, which are then submitted to the winding department for winding process. In addition to the laminations, other stamped steel components like fan cowls are produced at the stamping plants. Fan cowls formed by deep drawing of sheet steel are ready for submitting to the assembly shop after air inlet and fixing holes are punched. All aluminium ingots are molten at the electrical melting furnaces. The rotor bars in electrical motors require a very high-grade pure aluminium in order to provide the highest torque and performance characteristics. Whilst all aluminium parts are cast through a special injection process under very high pressure, hydraulic presses used in the injection of rotor bars are of medium pressure. The molten aluminium poured into the slots rises up slowly in order to make sure a good rotor bar casting without porosity or cavities in the rotor bars. All motor parts like frames up to size 200, end shields, flanges, and terminal boxes are die-casted with aluminium alloy. With the horizontal high-pressure die-casting machines, highly rigid aluminium components are produced. After cutting off the runners and cleaning the parts, they are stocked, ready for use of assembly shop. In the machining process, all shafts used in Gamak motors are subjected to 6 machining operations. The first of these operations is cutting and opening center holes. Relatively small motor shafts are processed at this machine by cutting the shaft, opening the center holes, drilling and tapping from one end. After cutting the shafts from big motors, they are carried to another machine to open center holes, drill and tap from one end. Second step is precision turning of shafts. Third step is knurling the shaft in order to obtain a press fit into the rotor. Fourth step is machining keyways in shafts. Machined shafts are pressed into the rotors. Fifth step is grinding off bearing journals and drive end shaft extensions. As you can see at this machine, the grinding wheel first grinds the rear bearing journal to a precise tolerance, and then the Malpos measuring instrument measures the surface roughness and feeds back to the computer. Then the grinding wheel travels to the other side and grinds the drive end side bearing journal to the limits fed to the computer. Finally, it grinds the drive end shaft extension and completes the operation. Consequently, concentricity is obtained. Sixth and final step is precision turning of rotor in order to give their air gap. Rotors, complete with shafts, are now ready for assembly. In this area, we do the finish machine work for our casted parts and components. Gamak makes extensive use of more than 100 CNC machines in this area. During machining of parts and components, our basic principle is to do the finish machine work in one clamping. Thereby, concentricity is obtained when all parts and components are assembled. The cast iron motor frame passes through a number of machining operations. The frame is clamped to this vertical turning machine. Upon machining of the front end spigot, the stator housing is machined in fine tolerances and finished by machining of the backhand spigot. They are machined in one clamping in order to obtain the concentricity when components are assembled. The next step is machining underneath the feet, terminal box seating surface, drilling and threading the holes at this vertical machining center. The motor frame is now ready for assembly. Flanges and motor end shields are machined again with our basic principle of machining in one clamping. The holes of the flanges and motor end shields are drilled at the CNC machines. All aluminium flanges and motor end shields are machined at fully automatic high-speed CNC machines. Parts and components ready for assembly are stored in semi-finished products warehouse. Enameled round winding wires are also produced in Gamak facilities. 8 mm diameter copper is first drawn to 2 mm and then to finer diameters through inline drawing machines. The inline drawing machines, operating synchronized with enameling machine, draws down the copper wire to exact diameters required, which are then fed in for enameling. Double-layer enameled winding wires are produced in thermal class C, which resists to a temperature of 200 degrees Celsius. All enameled winding wires produced in this facility are used only in Gamak motors and not traded. The slot insulation coils are brought in for slitting to different widths as required by the stator stacks. The stator stacks coming from the press shop are ready for winding upon inserting of the slot liners. Automatic winding machines are programmed and set to the values required by the winding data.
Don't stop.
The coils wound at these winding machines are transferred to the stator and inserted to the slots together with the slot closures. Phase insulation is made in all motors, irrespective of size. Leads are connected to the conductors and insulated with sleeves upon brazing of the joints. Upon lacing of the winding heads, the stators are submitted for testing. Large motor and non-standard motor windings are wound at automatic winding machines and hand inserted to the stator slots. Leads are welded to the conductors and the stator is ready for testing. The windings are impregnated by dipping in Class H resin and then thoroughly baked to ensure high resistance to vibration. IEC on 2009. The motor is loaded to its rated output, and upon reaching the thermal equilibrium, performance data like currents, input power, losses, torque values are measured and efficiency value is calculated as per IEC 60, 034, 2, 1 and related curves are plotted. Noise levels of our motors are measured at noise-free room. Shaded pole motors used to cool condensers of refrigerators are manufactured at this shop. These motors are available in 2 and 4 pole speeds with output powers from 5 watts to 24 watts.